how to do a titration. So there are two reasons why you might want to do a titration. The first one is to prepare a soluble salt, for example sodium chloride, and the second is to calculate the concentration of an acid or of an alkali. So you'll need the following piece of equipment. You'll need a pipette, which is this piece of equipment here, a pipette filler that will suck the liquid up to the pipette, up to the mark, a conical flask there, and a burette, which is this piece of glassware with a tap on it. So what you do is, using the pipette and the pipette filler, add 25 centimetres cubed, it's usually 25 centimetres cubed of alkali into the conical flask, and then add 3 drops of indicator. Typically you would use something like phenolphthalein. Fill the burette with acid, and then using the burette, opening the tap, that piece there, add the acid and slowly swirl the flask. When the indicator changes colour, this is called the endpoint, stop adding the acid. You then record the reading on the burette. So here are some burette readings that I've used and done myself, and we're going to read the amount on this. If you find reading a burette to be quite tricky, I've just made a video on how to read your burette, so you might want to go and watch that first. So the reading on the first burette here looks to me like it's 17.35. The reading on the next burette here is 17.50. The reading on the third burette along, it's not particularly easy to see, but I think it's 17.35 as well. And the last one is kind of touching about 17.20. So we now have to calculate what's called the titer, this thing here, the amount that we added. And what I didn't show was what the level started with at the top. So usually you start the burette at 0.00. Sometimes you miss it a bit, or there might be another reason why it doesn't start at exactly 0. And this is the start. So to work out the titer, the amount you add, you take away the start, the amount you started with reading, from the end. So number 1 is 17.35. Number 2 is 17.50 minus 0.15, which is 17.35. The next one is 17.35, and the last one is 17.15. So we've done the titration 4 times, and we're looking for results that are concordant. And concordant means the results are within 0.10 centimetres cubed of each other. So we're looking for results that are close together. So looking across, there's 3 values of 17.35, 1, 2, 3, and there's 1 value of 17.15. So if 3 of those results are close together, they're concordant. 1 of those results isn't close to it. So the results we're going to use are this one, this one, this one, but we're not going to use this one. So we would calculate the average of these results, which would be 17.35 plus 17.35 plus 17.35 divided by 3, because there are 3 results, and the answer is obviously 17.35 centimetres cubed. If you were doing a titration to work out the concentration of an acid or of an alkali, that's where you stop. You then go and use N equals CV and work out the concentration of the thing you're trying to work the concentration out. If you're using a titration to make a soluble salt, there's one more thing you have to do before you're finished. So if you're using a titration to make a soluble salt, you do exactly the same procedure as we talked about earlier, but then you have to repeat the titrations you've just done, but without the indicator. And what that means is you stop adding the acid when you know you've got exactly the right amount of acid or of alkali, so it's neutral. You then heat the solution until most of the water is gone, and then leave the solution to crystallise. So to prepare a soluble salt like sodium chloride by titration, you do a titration with the indicator. That tells you how much acid or alkali you need to add. And then you do the titration but without the indicator. And then follow these steps here and you'll end up with a pure sample of the soluble salt you want to make by titration.